we're going to talk about section 1.2 from your textbook. The authors, Mercer and Sebecki, they title it, Do You Have Anything to Add? But, of course, I retitled it in the notes to what it's mathematically about, like quantities and signed quantities. There's also going to be a touch of variables in there too, but you can kind of get that hint from the objectives here. So we're going to talk about change in quantities and signed amounts, and we're going to identify the units and use variables in a meaningful way. As opposed to just an X or just a Y, in order just to go through the motions, through the algebraic motions. We're going to simplify expressions and evaluate them and interpret them. This is a big one in this class. We are constantly asking you to interpret what do you even mean? What does that even mean? You've done some math. What does that even mean? And if you're going to answer meaningful questions and you're going to use data to answer or make decisions, then you're going to have to know what every answer means within the given context. And then we're going to go ahead and look at the graphing calculator and use it to kind of look at equal expressions. If we say we can simplify expressions, were they truly the same? Are they truly equal to each other after we simplify them? Now, this topic, like section 1.1, I felt like there was a lot of background that could go into this topic, even though it's only a few pages in your textbook. It's a lot of pages in your notes, sorry to say. But just because I feel like there's a lot behind what you are doing. So let's just start from the get-go and write down, what do we mean when we are asking for a change in the amount? People ask for change all the time. When you're at the grocery store, you ask for change. How much did it increase? Then you're asking for change. Well, did the price go down? Well, then you're asking about, did it change? So all kinds of change out in our reality. And this I'm actually going to write as a formula. So this is a formula. Change in the quantity is we'll go new amount minus the old amount. Okay. It is true that is very specific to a time-based context. So a lot of times when we're asking about the change in the quantity, we are really saying, what was it and what are we comparing it to now? So when I say the new amount, I'm really saying, what are we comparing it to and what was the other? So maybe I know this seems weird, the comparing to amount. And this I put into small quotations because you will never see this written this way in a textbook. This is pure Abby Bailey lay speak, layman. So, and comparing to amount versus other amount. Okay. So, just depending on the situation, and we'll talk about that. That is my dog. I don't know if you could hear him, but he is probably barking at any movement whatsoever on the sidewalk. Let's talk about temperatures. Okay, the following temperatures are recorded in Minocqua, Wisconsin. Here we go. Let's use it. So it looks like 2013, we have the low temperatures on these given days. And those have all been recorded. And now we're going to compute the change in temperatures from day to day and put them in the blank space in the table. Okay, so this is an interesting thing because, well, if we put a change, how much it changes right here, like do we write it here, do we write it there? It's very awkward. Nonetheless, from January 1st to January 2nd, it went from -2, or 2 below, and up to 12 above 0. So this negative really means 2 below 0 degrees Fahrenheit, and then it went up to 12 degrees above 0 Fahrenheit. So the change was actually an increase of 14 degrees Fahrenheit. So a lot of times what my students will end up doing is either write it on the top line or the second line, or they'll make these little arrows to say, okay, from here to here, this is the change. I'm actually okay with any of these. I'm going to go with what my students have created in the past. And I'm going to put a line actually kind of in the middle here. So I'm going to put a line that looks like, here, I'll draw it in pencil first. In the middle of that, okay. And, okay, so here's what I'm doing. I'll just create these lines really quick so that you can see them a little better. And fill them in here. Okay, so from a lot of times they will do something like this. They will say from New Year's Day to January 2nd, the change in temperature was 14 degrees Fahrenheit. And then it looks like it went from the 2nd to the 3rd, it went down 3 degrees. So down 3 degrees, change in temp. And then, okay, so that would be right there. And then here, it looks like it dropped another 7 degrees Fahrenheit. So it went down 7 degrees. And then let's see, from here to here, there was no change, 0 degrees. And from 2 to 9, from the 5th to the 6th, there was an increase of 7 degrees Fahrenheit. And from 9 to 10, let's see, that was from the 6th to the 7th of January, it increased by 1 degree Fahrenheit. Okay, so we're kind of seeing from day to day what is happening in the change in temperature, as opposed to just listing what is the actual temperature itself. So here, it says compute the change from day to day, put them in the blank space of the table. Done. But just to represent a few of these numbers to show where we got this, really what we were computing was what is the new temperature minus what was the old temperature. So here, the change in the quantity was the new temperature minus the old temperature. And that was a difference of 14 degrees. And so a lot of times we hear the rule, oh, when you're subtracting a negative, you add. You change a double negative into a positive. But there are many scenarios where 2 negatives does not make a positive. For instance, if I am sad and I break my leg, then all of a sudden I'm not feeling so positive. So there are situations in life where 2 negatives do not exactly make you feel very positive or turn into positive. I guess we could say we're going to grow and get better. But sometimes it really is, because what we're doing here is we're taking away a negative, or we're taking away something below. And when we do this, we are really, so when I envision a thermometer, right, we're up here at 12 degrees, and then we're really thinking, okay, well, here's 0 degrees Fahrenheit, and then down here is -2. So this distance right here is actually a positive distance. It from here to here, right? Taking away this actually finds the total distance or the total change from a +12 to a -2. So in this situation, it actually does. Taking away negative or the opposite of this negative, however you want to view this. Opposite of subtraction, maybe. Anyway, so that's where this comes from. And then the same thing will happen if we do this again. The new temperature was 9 degrees. The previous amount, or the old temperature, was 12 degrees. And, okay, so we're comparing the old amount to this new amount. And if you have 9 and you take away 12, then you're dipping into negative territory because you've taken away all 9, and then you're in debt, or in this case, below. So that is a change of, it's a decrease by 3 degrees, okay? So immediately I notice that all of these signs, as soon as I see negative signs here, I know that in my mind, even though they're not explicitly written, we're kind of interpreting these, okay, no change. Because we're looking at change, these positives are increases, these negatives are decreases. But over here, when we look at the signs, okay, those are all implied, even though we didn't write them. This one is negative. And these signs indicate above or below 0. So these signs mean something different than these signs because this is change and this is just the raw temperature. Okay, so what is the difference between the temperature on January 1st, got it, versus January 4th? Okay, so I'm going to take a peek, and we are looking at the 1st versus the 4th. Okay, well, on January 1st, it was -2. On January 4th, it was +2. I feel like the difference between these two is 4 degrees of Fahrenheit difference. This is 2 below, this is 2 above, and the difference between them is 4 degrees. Now, so immediately I know that the difference between them is 4 degrees. And if we're going to be real explicit about this change, this word difference is actually computing a change in the temperature. It's going, okay, so the new amount, 2 degrees, minus the old amount, or the old temperature, the previous temperature, -2 degrees. Okay, now when we talk about the difference, a lot of times we will force it to be positive. And so, so a little side note here, this word sometimes can be interpreted to be, we don't care about the sign, whether it's positive or negative, we just care about how far apart they are. And if that's the case, then we're really talking about the absolute value, okay? But in this case, we can write 4 and still use our change in quantity regardless of signs because it went from negative to positive, so it actually increased by 4 degrees. What significance does the sign of the change in quantity have? Well, because it's change in quantity, it really is indicating increase or decrease, okay? If you were told that the low temperature on December 31st, 2012, okay, so I'm just going to go up here, and they say it was -4 degrees. Okay, so up here, let's suppose for fun, we had December 31st, 2012, which is the day before January 1st, 2013, and they say the temperature was -4 degrees. -4 degrees Fahrenheit. Got it. Would the change in temperature from the 31st to the 1st be positive or negative? Well, it went from 4 below to 2 below, so this change, I claim, will be a positive because it actually increased in temperature or got less frigid. So this will be positive. And just to verify that, we would take the new temperature minus the previous or the old temperature. And here, get a positive or an increase in temperature. Okay, now I have some remarks. Several of them, apparently. My first remark is this, and it's kind of crazy writing it down, but I have to write it down. Not all data is positive. We forget that from time to time. Not all data. Okay, it depends on what we're measuring. Okay, so even if we're talking about depths of a sea, you know, we could have above and below sea level, all kinds of different measurements are positive and negative. We could talk about money that has positive and negative amounts. And the next thing that I feel like is remarkable is due to signs having meaning, it is very important to make sure when we're using our formula, we are using it in the correct way. So what I mean by that is if we had done old amount minus new amount, so for instance here, if we had accidentally done, here I'll make it in light purple, if we had accidentally done, let's see, the new amount, let's say that we had put -2 here, minus the old amount, but we accidentally put that was 12 degrees. So I know that this is out of order because the new amount is actually on the second and the old amount was actually on the first, okay, or temperature. And if we subtract this, so we're down below 2 and we are going further down by 12, would be -14 degrees, okay? So, and here I'm thinking of this as the opposite of down. It went up. So we were below 0 and then we went up to 12. Okay, so we know that if we do that, if we put this out of order, I'm going to put a big bam, bam. Okay, warning. This order of this formula matters because it gives us either the correct increase or it accidentally gives us an increase for a decrease or a decrease for an increase. So, due to the meaning of signs. Due to sign meaning, it is very important to take care of which amount we subtract. Order matters in that formula, okay? And it'll switch whether it's increasing or decreasing, and then it won't make sense in this situation. All right, another remark. Positive. Okay, positive has all kinds of different meanings. It could mean up. So it could mean above. It could mean go up. It could mean it's above. It could mean we saw with change an increase. Let's see. So movement. Oh, sometimes it actually means go to the right. Okay, so positive movement can mean, so it could be directional. Okay. Let's see. Positive. Increase, up, above. I'm sure there are others, but those are the biggies in terms of meaning. And then let's write down a few meanings of negative. Okay, so a couple of interpretations of a negative sign. The opposite of these. So, down, below, ooh, surplus, debt. Okay, no, not gross. Anyway, so let's see, above, below, decrease, increase or decrease. Sometimes it means moving to the left. Okay. You know, I don't write debt down just because I believe that to me in my mind means that you're below $0. So its meaning to me is below. And then my last remark is that signs can be very powerful with people, and when they interpret them and when they see them, they actually physically react. So what I mean by that is when you see a negative in your bank account, a lot of people feel ill. So signs matter to people. Just putting it in there. It's pretty remarkable in my opinion. All right, let's take a look at example 2. Table shows some changes in sales for the Prius from one year to the next in thousands of cars. Okay, so it says changes in sales. Maybe let's tag that just a little bit. Thousands of cars, right? Okay, so it says from 2002 to 2003, the change in sales was 5,000. From 2003 to 2004, the change in sales was 29,000. From 2005 to 2006, the change was negative 1,000. Okay, so just so that we are reading this and kind of interpreting what's going on here. If 20,000 cars were sold in 2002, okay, so over here, I'm actually going to put this in here. 20,000 cars were sold in 2002. Got it. How many were sold in 2003? Okay, I'm going to go ahead and start using this table, even though it hasn't told me to. But I know from 2002 to 2003, the change in sales was positive, so it increased by 5,000. So 20,000 plus an additional increase of 5,000, 25 grand. Okay, begin with 20,000 cars sold in 2002. Fill in the missing values of the table to find out how many cars were sold in 2008. Okay. Whoop. So 2004, 2005, 2006, 2007, and 2008. Got it. Okay. I'm also going to get out my handy calculator. Verification always feels good. All right, here we go. We increased it by 5,000. So let's see. Will that help? Yeah, it does. Okay, so first we increased by 5 grand. Then we are increasing to 2,000, or increasing by 29,000 to get to 2004. So increase by 29,000, 54,000. sold in 2004. From 2004 to 2005, there was another increase by 54,000 cars sold. Huh. So add to it 54,000 cars sold. 108,000. Okay, that makes sense because it just doubled. So in 2005, they sold 108,000 Toyota Priuses. Whatever. And then, sales took a dip. From 2005 to 2006, the sales went down $1,000. Okay, so 107,000 cars were sold in 2006. And then from 2006 to 2007, we saw another increase of 74,000. Okay, hold on. I did not decrease by 1,000 on my calculator, but now I'm going to increase by 74,000. 181,000 cars sold in 2007, and then a bigger dip. We're in a recession. Anyway, so here we go. So, and then it went down. So, decreased by 22,000. End up with 159,000 cars sold in 2008. Okay, thank you, calculator, for your service. Okay, so find out how many cars were sold in 2008. 159,000. Okay. During which periods of time were the sales increasing? Okay, well, you could look at this and say, when are we going up and when are we going down? But really, it shows us right here with the change in sales. From 2002 up to 2005, we saw increase. Increase, increase, increase. But then all of a sudden, in 2006, we saw it go down. So, immediately increase. So, 2002 through 2005, and then again from 2006 to 2007. When was it decreasing? Right here, when it was going down, when the change was negative and it went down by 1,000. So from 2005 to 2006, and again from 2007 to 2008. Got it. All right. So let's just talk about this and then we'll start again when it comes to example 3. So the process of having good information. First, I feel like we need to define a goal and we need to recognize the population that that goal represents. Okay, so define the goal and the population it represents. Okay. This is just a slimmed down version of the scientific process or a good statistical process. Number 2, plan for good data collection. Okay, and I write good on purpose. Everyone will judge you on this part of the process. If you collect bad data, they're just going to throw it out. Like, they'll just be like, nah, your conclusions are worthless. So, number 3, describe the data in a useful way. We talked about that a lot in section 1.1. So, describe data in a useful way. And then 4th, draw conclusions. Or sometimes a conclusion is that something happened back here and there was a mismatch and we didn't do good data or something, that's an actual conclusion in its own right. So draw conclusions. Maybe repeat this process. Typically, we want to know how one action affects some outcome. So as we do this, here, we've been talking about gathering data, representing data, and then sometimes we put it in bar graphs, pie charts, tables of values, and then we just added to our ability with the tables of values, and we can include change. How is it changing? Is it increasing or decreasing? How much is it increasing or decreasing? So when we talk about describing data in a useful way and drawing conclusions, we will be looking at that a lot, very heavily in all of this course, actually. Okay, in the next video, we'll start dipping in to actually using variables to represent the data we are collecting.